4.4 factoring. Now, when we're factoring, the thing we always want to do first is see if any of the terms have something in common that we could factor out. And then we're going to be using the box method. One thing to be aware is if for some reason you don't like the box method, you can factor like normal. But sometimes it's easier with a visual representation using the box method. You should have this written down in your notebook in big letters so I can see it. So if you're going to be showing me what your notes to get full credit, you need to have this written down. What do we have in common to factor out? That's always your first question to be asking yourself when you're factoring. What do we have in common to factor out? So I'm looking at this. What do we have in common to factor out? So when I'm looking at this, I'm looking at this term right here and this term right here. So when I'm looking at those two, it looks like I have a factor of 3 with 6 and 9. And I have a factor of 1n in between those. So I can take out a 3 and an n. Now when you factor something out, that's the same thing as I divided both of these by 3n. So what I would have left for this first term would be a 2 and an n. And what I have left for the second term, 9 divided by 3 would give me a 3, and n divided by n is nothing. So then I have a plus 3. Now when you're factoring, and if you factor something out right from the get-go like so, you do not always have to keep factoring. Sometimes you do. In this case, I do not. The reason why I know is because when I look at my ends, there's no exponent there. So now when I'm factoring, sometimes you can ask a question if you want to know if you have to keep on factoring, but if your ends do not have an exponent, a lot of times that means you can stop factoring, and this is completely factored. So this is factored here. I don't have to do anything else with it. So now I have a problem here. So now first thing again, before I do anything, I want to look at these terms. Is there a factor that I can take out of these three terms? No. 2, 5, 3 have no common factors. And if I look at x squared, x, and nothing, so I can't take out an x either. So now I'm going to set this up like we have been working with. So I'm going to draw my boxes. In my first box goes my 2x squared, and in my last box go negative 3. And you always are going to add to this middle term. So I'm going to write add to negative 5x. So remember from in class we multiplied these two together and I get a negative 6. So now I'm looking for factors of negative 6 that add together. Multiply negative 6, add to get negative 5. So if I look at this, I can have 6 and 1. One of them has to be negative. Or I could have 2 and 3. One of them has to be negative. Now why did I put the negative with the 6 and with the 3? Because that's a larger number, it's negative, and we're adding to a negative number. So now if I actually add these together, this gives me negative 5, and this gives me negative 1. Well, I want to add to negative 5, so these are my two terms. So I'm going to put my negative 6x and my positive 1x in. Now I'm going to factor out. So if I look across, what do these two have in common? That's just an x, so I can take out an x here. What do these two have in common? Well, my 6 is negative, so I'm going to take out a negative, and 6 and 3 can both be divisible by 3. So I'm going to take out a negative 3. And what do these two have in common? Well, 2 and 6 are both divisible by 2, and I have one x that I can take out. So I can take out a 2 and an x. And what do these have in common? There's nothing that I have in common here. So if there's nothing I have in common, there's always an invisible number, because every single number in the world can always be divisible by 1. So then my final answer here would be 2x plus 1 and x minus 3. So this is completely factored now. 2x plus 1 and x minus 3. So I'm done. So here's my next problem. And one thing about this is you need to be listening. So the first thing I should always do when I'm looking at these, I should look at, does the 4, 20, and 56, do they have something that is in common that I can factor out? Is there any number that I can factor out here? Yes, there is. All of these are divisible by 4, so I can take out a 4. So again, when I factor out a 4, it's like dividing each one of these terms by 4. So then I have x squared. 20 divided by 4 is 5x. 56 divided by 4 is 14. So now, when I'm looking at this, the other one that we did 2 times before, we were done factoring once we did that. But now since I have this x squared and an x and a number, so I still need to factor this. So one thing that I'm going to do right now is I'm going to write my answer down here, and I should have something in 2 parentheses. But this 4 also has to be there because we already took out that 4. Now I'm going to make my box. And my x squared here. I have my negative 14 here. I'm adding to get my middle term, which is 5x. And if I multiply these two together, my 2 boxes together, I get negative 14. Again, I'm multiplying between these two numbers. I'm multiplying those to get negative 14. And 1 times negative 14 is that. So I have 1 and 14. Now when I'm looking at this, my middle number is positive, so I'm going to put my negative with my smaller number. I have 2 and 7, and those are all I have. So I'm going to add these together. This adds to get 13. Nope. This one adds together to get 5. Yay! So my 2 numbers would be negative 2. X and positive 7x. So now I'm looking across, what do these two have in common? These two both have an x in common. What do these two have in common? These two both have a negative and a 2 in common. What do these two have in common? They both have an x in common. And what do these two have in common? They both have a 7 in common. So I already wrote part of my answer down here, so I'm going to fill in the rest right here. So I have x minus 2 and x plus 7. Now a lot of times people ask, can I go from this to this without doing this middle step right here? If you are good at mental math, then yes, you may do that. However, make sure to check your work. How do I check my work? Well, once I FOIL this out, so my first, outside, inside, last, you can FOIL this out. It should be the same thing as this. You should be able to check every single work that you have here to make sure you have the right answer. So technically, you should never get a factoring question wrong. That is all we're going to do today, so I should be able to definitely see these 3 problems in your notes for your notes when you show it to me. And I should also definitely see the problems which are at the end of this video that you have to factor. Now hopefully this was a little bit, whoopsies, hopefully this was a little bit easier since we have been practicing this in class, but we will still be practicing a lot of this in class. So if you need help with factoring, you have to make sure to ask, because there's going to be a lot of factoring in the second part of chapter 4. Lots and lots and lots. You, I'm talking to you. You have a great, grand, wonderful, wherever you are in your life right now.